4. Energy change in projectile motion. Without air resistance, the mechanical energy is conserved in a projectile. There's interchange of kinetic and potential energy, as the projectile is at different heights. The projectile has a maximum potential energy at its highest point, and the kinetic energy will be minimum at that point, usually not zero, as it still has a horizontal velocity. Figure 8.2f here shows the change in potential energy, kinetic energy, and total energy versus time. On the other hand, for potential energy, kinetic energy, and total energy versus height, the change is linear as potential energy equals mgh, and kinetic energy equals the total energy minus the kinetic energy. A player serves a volleyball at an angle of 13 degrees above the horizontal as shown. The highest height reached is determined by the vertical component of the initial velocity and the height at which it was served, 1.8 meter. Five. Projectile with air resistance. With air resistance, total energy of a projectile decreases along its flight. The work done against air resistance is larger when the speed of motion is higher. The trajectory becomes asymmetric. If it is launched at an elevated angle as usual, the path is always lower than the case without air resistance, and the maximum height and range are both reduced. Example 9 shows a setup used by Galileo. The ball is projected horizontally at x. As you may tell, the initial speed at x is determined by height h. The range r, which equals initial speed multiplied with the time of flight, when the time of flight is determined by the height capital letter H. In the solution, we will find the relationship between r and h, which may tell you the value of the slope of r squared versus h, given on the right. In example 2, the trajectory of a football is studied. Note that the magnitude of the vertical velocity of the ball at kill does not change in the elastic collision with the ground. Only its direction changes from downward to upward. Now please do Bk2Chp8 on the next page.